Food is energy. Humans revolve around energy and their health around food. Math is the building blocks of our world. Humans revolve around math in everything we do. Thus, math is in food. Can you taste it? Probably not. But mathematical procedures, formulas, methods, and more are the essence of each new food you purchase. The relationship of food to ourselves always poses questions. Autoimmune disorders are often treated in part with a diet of cooked vegetables, fruits, and bone broths. Why cooked vegetables? Why bone broth? How does this have any effect or support for people with autoimmune disorders? How do companies develop grains or meals? How did the idea of a balanced diet come to be? Diving into the world of food, math applications vary from optimization to threshold calculations of toxins and biochemistry rat experiments. And through these math applications in sciences, we have come to understand the apple, and the carrot, and cereal, or toxins, salmonella, and oxalates. From our earth to our plates, to our well-being, what humans have come to do with food and math is an unforeseen partnership that builds the pies and pastas and breads we love so dearly in the most beautiful way. Let's start with rats. Math is highly used in biochemistry experiments, and in many cases, experiments with rats. For example, a 2022 study by the Journal of Food Biochemistry posted rat testing on yogurt supplementations for grains and bran to see the effects on rats with high cholesterol and how supplementations would change their serum lipids profile and liver and heart functions. This kind of mathematical experimentation finds patterns and uses numerical data to derive a conclusion. The rats were divided into groups, some getting all yogurt, some only grains, and some a mixture of both. From the data, the hypercholesterolomic rats that received a mixture of yogurt and bran reduced serum glucose from 113.9 plus or minus 2.7 units to 85.5 plus or minus 4.94 units compared to the rats with no yogurt. This data analysis can conclude that a mixture of yogurt and grains will lessen the risk of the cardiovascular problems and aid liver or heart functions within hypercholesterolomic people. This pattern recognition is a mathematical branch of cybernetics. Cybernetics is defined as the science of the control, communication, and processing of information. And within this, the mathematical process is defined as an algebraic approach to the solution of pattern recognition and identification problems. The Encyclopedia of Mathematics explains how devising principles and methods for the classification and identification of objects and situations can be described as a finite set of features or properties characterizing the object. These sets of features or properties in this case would be the serum glucose levels in the rat's lipid profile or the data on their heart and liver functions. By math, pattern recognition first factors in other information, in this case the rat's initial hypercholesterolomic conditions, then introduces a test sequence. This would be the 4 weeks of diet testing, and finally must have an algebraic framework, in this case the initial versus the final numbers to come to a conclusion. 4 weeks of yogurt and rats alongside a splash of process analysis, and boom! Thousands of people with high cholesterol can use a new technique to better their lives and still eat yummy foods. Now, have you ever wondered how scientists spot foods that have gone wrong? Another way math is used in food sciences is Raman spectroscopy. This mathematical application to chemistry is used to determine quality attributes and hazard detections in foods on a molecular level. Raman spectroscopy, in short, is a lab technique that vibrates molecules using high-energy photons, and the reflections recorded can determine the molecular structures in foods, which can then be analyzed to determine hazardous or find information. The mathematical formula of the change of velocity equaling 1 over lambda 0 minus 1 over lambda 1 is used to convert the electromagnetic spectral wavelengths recorded to a usable wave number. Here, contaminants such as pesticides or heavy metals can be detected to warn of salmonella, E. coli, listeria, or other diseases. We can all thank just a handful of protons and some math for keeping our foods safe. Next, this might be familiar to calculus students as we use derivative methods to minimize or maximize word problem situations. In food sciences, optimization is used to maximize efficiency in development of new foods, processing items, cutting costs, and so forth. As technology develops and is intertwined in industry, these calculations are often done by programs. However, the underlying calculus that we know is the basis for such operations. Math to me is extraordinary. In a way, math is as essential to modern life as food. You can find math in everything, and thus you can find stability and ways to innovate in everything. Food sciences, like any sciences, uses math's complexities and simplicities to better the best thing in the world, which is food. And that in itself is simply beautiful.